All right, in this video, I want to tell you some, as it says, important final notes about parallel circuits. We talked about this with series circuits. We mentioned that series circuits are always high resistance, low current circuits, so we don't use them very much. Well, parallel circuits are different. It's the exact opposite. Parallel circuits, because we have multiple pathways, y'all, because we have more than one lane of traffic, so to speak. By the way, that's kind of what's going on here with the high current, is that it's kind of like multi-lane traffic that's going on, and we're going to get to that. Parallel circuits, you need to know, are inherently low resistance circuits and high current circuits. Low resistance, high current, because we have multiple pathways. Remember, the resistances are going to add reciprocally now. They don't add arithmetically. So that means that as branches with resistors are added, we're adding resistors, the equivalent resistance actually is going to go down, which might not make sense to you because it was the opposite in series. In series, when we add resistors, total resistance goes up because we just keep adding and adding. Well, now, as we add resistance, total resistance actually goes down. Let me illustrate that for you. Here was the circuit we were working with, and we found that the total resistance with this one was 0.63. That's what it was. So let's imagine now that we just add another resistor out here. Let's say we add another 5 ohm resistor. We've added more resistance, so you might think resistance might go up. Well, watch what happens. Let's add it reciprocally just like we did before, 1 over 10 plus 1 over 2 plus 1 over 1, and then we're going to add this 1 over 5, a new reciprocal to add. We get 1.8, and remember, that's not the answer. We have to take the reciprocal of that reciprocal sum. 1 divided by 1.8 gives us 0.56. The total resistance went down from 0.63 to 0.56. And the reason it went down is that it's not really about adding more resistors. It's really about adding more branches. Think about when you're driving on the highway. When there's another lane opened up, the traffic can flow better because we've added more space for the cars to go through. That's kind of like less resistance. So even though we've added another resistor on that branch, what we've really done is added less overall resistance because there's another pathway for electrons to flow through. So resistance goes down as we add branches with resistors on a parallel circuit. Now, because resistance goes down, you need to know that this is potentially dangerous. The reason it's dangerous is because as we add more branches with resistors, as we turn more stuff on, we can go out and out and on and on and on. We just proved that equivalent resistance goes down. Well, as resistance goes down, we know that current goes up. So that means we end up with potentially very, very high current, especially in the main line, because this line has to have enough current to serve all those branches. So we get really high current in the main line. That current can easily get really high. We get hot wires because friction is what's happening as the electrons are going through those wires. The insulation on the wires can melt, and we get a fire hazard. So this is an inherent hazard potentially with parallel circuits. It can be dangerous, and this is the reason why we have circuit breakers. So you may not have known circuit breakers, but I know you've seen a panel like this in your house. This is your circuit panel. It might be in your garage, maybe in a closet in your house, maybe in a panel outside your house, but this panel has all the circuit breakers on it, and all these circuit breakers are installed on the main line of the circuit. There's multiple circuits in your house, and you put one of these on the main line, and it's basically just a switch. It's a switch that monitors the current all the time, and when that current gets too high, it automatically trips, it shuts off, breaking the circuit so that we don't get a fire, so that we don't get that high heat. This thing right here, the whole purpose of it is to protect you and your home from fire damage. And it's necessary because of this next point. So multiple pathways means parallel circuits are dangerous, but as long as we have these safety devices in place, they're way useful. They're extremely functional because of the multiple pathways. They're used almost exclusively in residential and commercial buildings because, and this is the good thing, every light, every plug, every device has its own direct connection to the power source. So it can be operated independently of everything else. I can operate R2 all by itself because it has its own direct connection to the battery. I don't need to operate R1 and R2 and R4 to turn all of it on, right? So imagine if your home was wired in series, the only way to plug your phone in and charge it is if you plug something in and turn it on to every other outlet or every other light switch on that circuit if it was wired in series. Remember, I showed you a series circuit before. And in a series circuit, everything has to be operational for anything to be operational. So parallel circuits are, number one, dangerous, right? We can go back here. We can get a fire danger because we got a high current circuit. They're inherently low resistance, high current circuits. But as long as we have working circuit breakers, which most of the time we do, then we can guard against this. And also, this also depends on not having circuits that are too big anyway. The bigger the circuit, the more likely it is we're going to have too much current running through the main line. But that means as long as we can keep it safe, these are extremely, extremely useful. We use them almost exclusively in buildings and in homes, which also means, as you might have seen before, remember my parallel circuit, it's really complicated, which means there's a lot of wire in homes and buildings, lots of copper. That's the reason why copper costs a lot of money. It's very valuable because of wiring in homes. So these are some important things to remember about parallel circuits.